Right, shall we get on?
I'm just preparing my mind. Hello my aviation chums, welcome to A Chopper is Born. Today we're going to be putting on the rest of the pulleys and belts to run the tail rotor and putting the clutch in, and also the chain oil bath. You can't wait, can you? Yes, I'm building my own helicopter and it is coming along a treat. There she goes. This is the engine that's going to power my chopper. A lot neater, I think you'll agree. I've got an appointment with my flying instructor. Oh, no! The tail rotor at the back is driven by a system of belts and pulleys that come from the secondary drive unit and then through two other pulleys that are within the tail boom, and they're at slightly different angles, so they can take a horizontal drive from the secondary drive system near the engine through to a vertical drive where the tail rotor is. So it's quite a simple but very clever little device. Now I've already put one pulley in, I've got one more to do, and you can see here where the alignment of that pulley is with the bulkhead, so you can see that it's on an angle. The belt itself looks as though it's not strong enough to run the fan in your average family saloon, but it is incredibly strong. It's made of stuff called aramid fibre, which, unlike normal belts, when it gets hot it actually tightens rather than slackens. So your life is in the hands of this belt. If it had hands, of course, which it hasn't, because it's a belt. People have hands, belts don't. First job is to put on a test marker for heat, which has got to stick onto this pulley. And basically you can see here there are numbers around the outside. You've got 170 here, 180, then 190 and 200F. And it's a heat detector. Now if the pulley itself reaches 170 degrees, that little silver dot next to the 170 will turn black. That's a warning sign when you're doing maintenance. Maybe you've got a loose belt. Now that's got to be stuck on there. First job is to just clean up with acetone, just to get rid of all the rubbish, and then you borrow Pete's nail varnish.
It's not mine.
It is yours. Look, don't fight it, Pete. And then it needs to just go off until it's tacky. How long does it normally take yours to go off, mate?
About a minute.
About a minute, okay, cool. But it's a bit cold today, so it might take a little bit longer. Okay, leave that for now, just to go off a little bit. The attachment of the pulley to the bulkhead is very straightforward. It's a couple of scissors. We need to put on this bit, which is the spindle, and then it'll attach the pulley with these two little hubs either side, but I'll put those on once I've stuck the sticker on. Right, now, that looks tacky. When you going to start using colour, mate, rather than just clear? No? There we go. No problem at all. Put these two hubs in and fit the scissors. And then a bolt goes through the two, right through, there we go, and there you have it. One assembled pulley, all needs tightening up, and then I can put it in the aircraft. The pulley fixes onto the bulkhead in here, and fortunately in the tail boom there is an access panel which allows you, A, to fit the pulley, and also obviously to check that heat strip when it's all built and running. The scissors just slip into a bracket with a couple of holes in that's already fixed to the bulkhead, and then there are just a couple of bolts. One there. First one went in beautifully. Now this one. Come on! Have you just got a pin I can put through here to just check this is in line? Oh, there we go. And then it's a case of popping in the bolts. Oh, where's that gone? Oh, there it is. Yeah. And this will not go in. Oh, come on. The simplest job is always the most difficult. Right, just tighten those up and then I can take the pulley out. That is the end of that sequence. The pulley's out, here's the belt. It goes onto the bottom of the two slots in the pulley like so, but I need to feed up first the belt down to your end. The belt coming from the tail rotor end needs to be in the top groove of this pulley, like so, and then the whole lot needs to slide into the scissors, and then one big bolt through the whole lot, like that. Right, well this axle bolt for the pulley needs to be done up completely tight, and then I can attach the belt to the secondary drive. So, the belt should, just pull it taut, should just slip on to there without having to stretch it or anything. Now, does that move the tail rotor? Yes, indeed! The magic of science!
CNC is computer numerical controls. It's a 4-axis, 5-pallet horizontal milling machine. This machine can face off parts, X and Y axis and Z axis, so you have 3-dimensional milling, and the pallet will also rotate, which gives it the 4th axis. This machine new is, with its tooling, is about $1.5 million. Tombstone is the big square block that we're going to mount the parts to. The operator initially is going to bring the tombstone over into the loading station, the loading dock. He will physically load the part onto the pallet. The operator will then activate the program that's going to machine that part. And here we have a panel that we use to activate the different programs for the different parts that we have loaded in the machine. This machine has 96 tools that are ready for whatever operations that we're going to do. The machine will automatically rotate those chains around, bring up the appropriate tool, and load it into the machine. This is the inside of the case. So these are the 2 mating surfaces that are completely flat now. On the back side of this tombstone, we have cases that had already been machined, and the opposite face was cut perfectly flat and parallel to this interface. Here we have the cases which have just been fly cut. We can see the pallet coming out. The point of having this machine in the factory is so that we can get very accurate to within a 1/2,000 of the tolerances. And we can have this repeated time and time again and get consistent parts.
Next job, the clutch. Pete, mate?
Yeah.
Have you got the basic assembly for me?
Is that it? I mean, it doesn't look a lot.
It doesn't look a lot, does it really?
No.
But this is the main workings of the clutch, which there's quite a lot of assembly work to do on its bracketry, but it will fit in here. Something like that, which means when the clutch is engaged, this arm will move this big pulley here out sideways like so, which will tension the belts, and that's controlled with a rod lever that goes through into the cockpit. So it's a bit of a bench job. Okay, please take a long hard look at this plan, and when you've worked out what it's all about, could you let me know? This is a very complex looking drawing, but if you get rid of all the kind of superficial stuff you don't need to know about and concentrate on the middle, you can see there's the top of the pulley looking down on it. And this is the main frame it sits in. That's the arm that goes to its hinge point there. And then we've then got this connector here, a bracket there, and then this that continues here is actually the lever that goes into the cockpit, which is there. So you can kind of ignore everything else on there for the moment. And the first job is to properly attach the pulley to this arm here, which is number 21, which is the pulley arm weldment, E279010. Next up is preparing the clutch tube weldment, which is this bit. We've got some springs to go in there. This will slide in there like that. Well, Pete, mate.
Yep.
Can you just drop that rivet in? All right, mind your nails.
Yeah.
Mind, just use the base of your thumb. Okay. Sorted, and there you can see it just acts as a stop, a backstop for the piston. But the piston is free to move up and down like that. Right, that's the pulley and its arm attached, so it can swing there and engage the pulley onto the belt. Next, the other clutch arm, which has one bolt underneath and then another bolt in the top, like so. And you're beginning to get the idea. So that's it for now. Don't go away though, join me after the break when I'll be putting in, now which way around was it, Pete, mate? It's the chain oil bath. Not the oil chain bath, isn't it? That's the one, in a couple of minutes. Welcome back to A Chopper is Born. My two-seater executive helicopter is evolving very nicely. Now you can tell that firstly by looking at the helicopter, and of course we've got more bits on it than before, but more satisfying is the fact that my empty tray is filling up very nicely. We're just finishing off the drivetrain for the helicopter, which basically takes the turning of the crankshaft of the engine down here through a system of pulleys and cogs to be able to drive the tail rate at that end, a few other bits and pieces that are to do with the engine, but also the big wheel up here that turns our main rotors. Last job before the break was just fitting the clutch here, and you can see now that that works very nicely. When it's engaged, this over center arm here locks into place and pushes this pulley right out to tension the main belts. But when you take it off, what is very obvious is the main belts are far too slack. So I've already tensioned up the drive belts that go to the tail rotor, and the same principle is used to tension these main belts. You need a gauge, a bit of wire, and a little piece of aluminium cut to 1/2 inch on the end of a piece of string. All will become very clear in 2 seconds. The adjustment for the belts is done down here on this bolt. As you screw this in, it pushes the top of the engine towards the front of the aircraft, which tensions the belts. Okay, that's tightening up a bit, so let's see whether we're anywhere near the tension we need. So what we do is get your bit of wire, hook that underneath the bottom belt, attach the gauge to the other end of the wire, and then this is effectively your depth gauge, or marker gauge, because the belts are at the right tension. When you're pulling 7 pounds on here, the belt should move out of position the 1/2 inch width of this little piece of aluminium. So we've got 7 on there, and you keep fiddling about until you get it right.
Welcome to Hot Shot. My name's Craig Hook. I've built a Rotorway Exec 90, manufactured in 1991, got it together in 93, and been prettying it up ever since. It took 575 hours to get the machine together and flying, probably 1,000 hours more for the paint and the interior, the other fancy things that we put on it. They make their own engine. It's a 162-inch displacement, water-cooled 4-cylinder. They call it a Rotorway 162F. The F stands for FADEC, or fuel injected. 150 horsepower. Turns the blade 520 RPMs. Tail rotor's about 2,600 RPM. We didn't have any main problems at all. The manuals were very explicit with their detailed drawings. Very straightforward. You need to be able to turn a screwdriver. You need to be able to fabricate some parts, but nothing that the average person, I don't think, is going to have a stumbling block.
This is the chain oil bath, although it needs a bit of fabrication. It comes in 3 bits. 2 bits make the lid, but we're not working on that at the moment. Just looking for that. Pete, mate.
Yeah.
Found it.
No, thanks a lot.
It's yours. All right. Over here is where the oil bath will go. And this main tooth cog will sit in there. And the other one that sits on top of there for the other end of the chain will be inside here. And it is to bathe and lubricate the chain. It's got to contain oil. But no ordinary oil, because it's a mixture of good high quality engine oil mixed with this very gloopy stuff that is very like treacle, almost good enough to have on your porridge in the morning. And that thickens it up nicely. So it's not a huge amount of oil goes in this bath. And actually one of the jobs first thing in the morning when you've got the helicopter complete is you tip the helicopter back a little bit so all the oil in the bath runs back down to coat the small cog, and that then will get all the oil on the chain, so when you start running up you've got the whole thing lubricated. First job on the bath itself is to cut 2 holes, one for the primary shaft, one for the secondary shaft. What I'm doing here is creating a little access hole where we'll end up putting in this link pin here for the chain. That'll go up through that hole. So it's only a little hole, but the next bit of kit to open up the slot is this thing, which is a step drill. It means you can start with a pilot hole and then just open it up to whatever size you want in one go. Oh, yes! There you go, that looks good, excellent. This will then sit over secondary shaft, like so. And I've got an oil seal here. This will glue in place finally, but be left dry for now, but that'll help centre that end. So that's fine. Now, the idea is I've got to mark from underneath where this square section tube on the airframe is, because I'm going to need to drill 2 holes down here to fix this to the airframe. Pete, mate, can you just keep this end centred while I try and mark it underneath? There and there. And then we can drill it. I've drilled the 2 holes in the square section tube there, and I'm just putting on some non-corrosive silicone. Right, I think I'm ready for chain bath. If you can take that off, clamp off, and then take the 2 sleeves. Got them?
Close it out.
Coming down. Give it a tap. It's not Morse code, it's trying to get a thing in the bearing. That's it, it's nothing in, it's going, it's going, it's going. Lovely jubbly. Now we need a little cog, the other end. I need to clamp on this cog onto the secondary shaft, so it's just a process of sequentially tightening up these Allen key bolts to effectively squeeze the cog onto the shaft. Okay, sorted. Next, the chain back on.
Hey, taking off from the ground. Bring up my RPM. As soon as I get RPM, I'm immediately going to pull pitch. I'm not going to come to a hover. As I leave the ground, I'm going to immediately start forward into forward flight. There we just entered translational lift, which is basically increased performance due to more airflow through the rotor disc as you gain airspeed. To execute a normal takeoff from the hover, we begin taxiing forward, continuously increasing our airspeed. At 15 miles an hour, we enter translational lift, I'll maintain 65 miles an hour on my climb. That's going to give me my best rate of climb. Okay, to execute a max performance takeoff, as I begin my forward takeoff movement, I increase collective pitch and throttle to maintain rotor RPM, and that establishes a more vertical climb to climb out over a confined area to clear an obstacle. Once we're clear of that obstacle, I reduce the power back to the hover power setting and resume a normal climb out profile.
I've linked the chain together from the top with an old connector link, but you can now see why this little access hatch is in the bottom here, because the actual pin has got to come up from the bottom, and then as it comes out, to put in some little spacers in the chain. Last little link over the top, and then this clip, which will be eventually painted white so you can see it more easily. There we go, one chain sorted. Now there's quite a lot more work to do to this in fabricating the lid, also putting a safety spacer on the main shaft here. But once all that's done, we can put the oil mixture in and seal all that lot up. But first let me show you how this will all work in normal operations. The engine here will drive the primary shaft here with the belts on. These will take the rotation back to the secondary shaft here with the big pulley on, which connects with the tail rotor, but through that secondary shaft, and then the little cog on the top and the chain drives the big cog here, which drives the main shaft and the rotors. That's all good and well, but what if the engine fails? Well, thanks to the freewheeling sprag clutch in the secondary, as the blades continue to rotate, with the engine stopped, you can keep your tail rotor turning, which means you have complete control over the helicopter to get back down to earth safely. Now that is a very cunning, life-saving bit of engineering. That's it for now, we'll see you next time. Tell you what, Pete, mate, I think I'm getting the hang of this. Should I get a bigger one?
Do whatever you want, mate. Busy.